Hello, good evening everyone. I welcome all of you to Gradeup channel, a YouTube channel of Gradeup. So today is the last session for strength of material BARC, and we'll be solving some fantastic questions. All of you please join together. All of you please join together. And please tell me whether I'm audible or not. Hello. Hello everyone. Come on. Let me share this. So all of you please join as soon as possible so that where is that one? Hello Kavya, Vivek. How you all are doing? Join now. Audible and visible. Okay. Give me just a minute. Need to share some location. You also please like and share. Then within a minute we'll start this one. Okay. Now it's done. Why it's not running? It's live, right? In my mobile still it's not running. What about? Okay, now we can see. Hello Atulya, Shruti. Welcome all of you. Okay, let us start now. Without delaying much. Come on. Without much delay, let us start our session. So this is the last one, as you know. Those who are here, please join the Telegram channel, and today I will be sharing all the PDF, right? But see, only seeing the PDF doesn't help a lot. At the same time, one should attend the classes also, right? You please do not forget to share and like, and you can join my Telegram channel also. In your chat box top, if you see, Telegram link is given. Batches are going on for Vision 2022 in English and Hindi as well, so you can enroll there. Mega mock challenges are going on, that also dates are provided for the gate and BARC. You can sit for it. First problem in front of you: what is the vertical displacement at B? Where is the joint B? B is here. Can you tell me what is the vertical displacement at joint B? Yes, Swamijit, good afternoon. What is the vertical displacement at joint B? So it's a good practice session, those who are going to sit for the examination, isn't it? Please solve it and tell me. So if you are trying to calculate the deflection at B, obviously you know what will happen here. You'll get two type of deflection, right? So W into L is the moment which you are going to get here, and due to the moment, what is the problem? Due to the moment, there will be a rotation. What is the rotation here? That is ml by 3I, isn't it? ml by 3I. Now that ml by 3I, what is that m? M is nothing but w into l. So you have a slope due to that rotation. First of all, your beam is going to get rotate, and due to the load, the beam is going to get deflect, right? That is how you are solving it, isn't it? That is how you are solving it. So you have a two type of deformation. That is one due to the rotation. So if rotation is there, the theta is nothing but ml by 3I, isn't it? Correct? ml by 3I, that is nothing but wl into l by 3I, that is wl square by 3ei is the theta, multiply with the length, that is r theta. It will become wl cube by 3I, right? wl cube by 3I. How much you are getting? 5pl cube by 6ei. No, rotation is correct, right? Theta. How much theta you are getting it here? Both have same length. For the moment applied at this location, what is the theta? Theta is ml by 3I, correct? No. That ml by 3I multiply with the ml by 3I multiply with the r, that is length. Yes, that is why I asked once again. I have seen your answer, and that is why I asked once again. So wl cube by 3I r theta, isn't it? This is your r theta. Yes, Naveen, absolutely correct. So practice it. This much of problem, if you're thinking, will not come. I'm really sorry for that. You practice. These are the very common general problems, right? So r theta is there. Then after that, due to the load, it will get bent. So the bending will occur. That is nothing but pl cube by 3I. So w into l cube by 3I. L cube by 3ei. Now wl cube by 3I here, wl cube by 3I here, it will become simply 2wl cube by 3I. Or if it is p, I'm really sorry, it has been given in terms of p, but no worry, right? No worry. Simple or not, it is simple, very simple. wl cube by 3I, and once again you will get wl cube by 3I. That's all. Twice of the wl cube by 3I. Any doubt? Find the horizontal deflection at A. What will be the horizontal deflection at A, or horizontal displacement at A? Can you? A very kind request to all of you, please share it. Please share the session with all. What will be the horizontal deflection at A? Tell me. Why the horizontal displacement at A will occur? Is it due to the load applied at A? No, it is due to the rotation which is going to occur at B. That is nothing but P into this length, suppose L. P into L is the moment which is acting here. What is the theta will be created? What is the theta created? Sorry. What is the deflection created by P into L, that moment? The deflection created by this moment at joint B. That is the deflection. Yeah, that moment. The moment, whatever the deflection it is going to create here, that deflection, what is that value? Can you tell me? What is that value? ml square by 2ei, is it correct? ml square by 2ei. ml square by 2ei. If it is not visible, I'll write down here. Delta is what? ml square by 2ei. Now what is m? The moment itself is p. pl cube by 2ei. That's all. It is asking about horizontal displacement. You can do it another way also. Write down the total strain energy. From A to B you integrate from 0 to L. Then for B to C you integrate. Add those two. Find it out what is the total strain energy. Use the formula m square dx by 2ei. Isn't it? M square dx by 2ei. Then after doing the calculation, partially differentiate, but you cannot do that. Here your pseudo load must be applied. So the Castellan application is long. You can do that. Apply the pseudo load here, and then now you do it at your home. Do it. You got the answer, right? You got the answer? PL, is it PL square by 2a? How? ml square by 2a, it will become pl cube. No, p into l is the moment. P into l is the moment, that is p into l, then l square. No, what is that? Deflection due to moment. Okay, pl square by 2a, that it will become pl cube by 2a, isn't it correct? No, okay. Find the deflection at a, that is he is asking about the vertical displacement. Find the vertical deflection at a. What will be the vertical deflection at a? How you will do that? Simple, very simple. The first question, have you seen that first question? Similarly, you have to apply the, see, due to the P into L, this part will get rotated. Due to the rotation of the joint B, as it is a rigid joint, first of all, the BA will get rotated. Without deflection, just to try to understand, first of all, it will get rotated to maintain the angle, that is 90 degree. To maintain the angle 90 degree, it will rotate. So at first deflection, you will get due to the rotation only. And then what? As the load is applied there, it will be deflected now. It will be deflected due to the load, and the next deflection you will be getting it. Is it visible to you? Delta 2. Right. So now delta 1 is nothing but how much? So once again, PL is the moment which is acting here. P into L is the moment which is acting. What is the theta you will get? ML by EI. Theta here is what? ML by EI. So delta 1 is nothing but once again R theta, that is L into theta. L into theta at B. Theta at B. And delta 2 is very simple, PL cube by 3I. PL cube by 3I, isn't it? So now delta 1 will be L theta. So L into ML, that is theta is what? ML by EI. So now ML by EI, I'll write down ML by EI. That is delta 1. And M is what? M is once again PL. So PL cube by EI. PL cube by EI. Now PL cube by EI is the delta 1 and PL cube by 3I is the delta 2. And what is the final delta? You add it. How much you'll get? PL cube by EI plus PL cube by 3EI. कितना हो जाएगा? 3 1 नहीं, 1 3 3 और यहाँ 3 4 by 3. 4 by 3 PL cube by EI. Correct? Correct, no? 4 by 3 PL cube by 3EI. 4 by 3 PL cube by EI. Look at that. Where is that? Here. Find the horizontal displacement or at the roller support. Find the horizontal displacement at the roller support. This is so quite, I don't think it may come. But this is just for a practice. I don't think this much will come. So to calculate the horizontal displacement, what you'll do? This is your length of the beam, a complete length of the beam. What is the complete length of the beam? You can simply apply the Castigliano here, isn't it? The Castigliano can be applied, but what is the length of the beam? Generally, you are writing down the strain energy, that is m square dx by 2EI. Here, it will be not dx. Over the length of the beam, the total strain energy due to the bending must be added together. So now, dx is not there. Here it is a ds. That length of the beam, small portion section of the beam, if you take, that is ds. Now maybe if you are taking the bending moment at some location, maybe here, what is the bending moment here? So at this section, if you see the bending moment, the perpendicular, now what is the distance? See, towards this side, there is only one load acting here, that is P. Now this P is acting at what distance? This is the perpendicular distance. If this is R, it will be R sine theta. This will be R sine theta. So bending moment will become PR sine theta. PR sine theta. P is the load which is acting, R sine theta is the perpendicular distance. Put it there and you will get the strain energy. Now strain energy can be calculated as you are keeping it in terms of theta. One should integrate in terms of angle only, right? And integrating it how? How you will integrate? 0 to pi by 2. You cannot integrate from 0 to 180, otherwise it will become 0. 0 to pi by 2. Integrate for the 90 degree and then you multiply with the 2. because of the symmetricity. Now it will be m square ds by 2ei. So m square means p square r square sine square theta. Ds is nothing but r d theta for any arc. For any arc, if it is ds 1, you know that, right? If it is d theta, if it is ds, so it is ds is nothing but r d theta divided by 2ei. 2ei, this 2 will get cancelled, and sine square theta integration from 0 to pi by 2. So what you will get exactly here, p square and r cube by p square r cube by how much you will get here, ei is the common sine square theta. If you will integrate from 0 to pi by 2, you will get pi by 4. That p square r cube by 4a, that is what you will get strain energy. Then partially differentiate your strain energy with respect to p, and you will get the deflection in the direction of the application of the load. Do that, and what you will get exactly here, the delta will become, see, 2p and 2 will get cancelled. So finally you will get p, then r cube, then pi, then 2a. That's all. So it is the first one, first option. First option is the correct one. Did you get that? Calculate the critical load for the strut, which is made of a bar of a circular section and 5 meter long, pinned at both ends. The same bar, when fixed at one end and load applied at free end, gives a deflection of 10 mm under an 80 Newton load at center. The same bar, when fixed at one end and load applied at free end, gives a deflection of 10 mm under a 80 Newton load at free end, I think, not at center, at free end, right? If it is, the bar is fixed at one end and load applied, fixed at one end means what? It is like cantilever portion. Cantilever, when the bar is fixed at one end and load applied at free end, so it is a cantilever portion. How you will solve this one? What is the answer for this one? Same bar, when it is cantilever, he is saying that when it is cantilever, if you are applying the load is already 80 Newton. The deflection you are getting at the free end, he has already given, that is nothing but 10 mm. 10 mm. Now use that one and tell me what is the critical load for the column when the column is hinged or pinned from both ends. Yes, the calculation must be done here, right? Calculation must be done here, because the P critical already you know. What is that formula for P critical? Pi square EI by L effective square. Am I right? L effective, once again, if you see here, calculate the critical load for the strut, which is made up of bar of circular cross section, 5 meter long, pinned at both ends. If it is pinned both ends, L effective will become simply L. Now we don't have EI, right? EI we don't have. For EI only, we will be searching it from this one. What is the deflection? That is, deflection is nothing but PL by 3I. PL by 3I. So use that EI by L square. So keep it here, that EI divided by L square will become P into L divided by 3 into delta. What is that P? EI by L square, I am using it because already we have EI by L square here. Directly it will become easy calculation for you. So PL by 3, is it correct? PL by 3 into delta EI. Okay. Now, yeah, that P already given, that is 80 Newton, and length of the bar is already, length of the column is given 5 meter. Maybe you can keep it, okay, that 5 meter, keep it as it is. Then 3 into, what is the delta value? The delta is 10 mm. If you are keeping it in meter, the delta also must be changed. Change it to what? Change it to meter. Now finally, how much you are going to get it? 8 by 40 400. So 4 by 3 and 10 square. So it's 10 power minus 2, and finally you get 10 raised to 4. Correct now? Here 10 square by 40 400. So 400. So yeah, 400, then 10 power minus 2, it will become 10 raised to 4. Right. Now use the same one here, P critical. Now what is that? Pi square into EI by L square is how much? That is 4 by 3 into 10 raised to 4. So calculation is very easy. No one was doing that. Maybe you are thinking that it is too much of calculation, right? Where is the calculation? See, pi square value has been given as 10. Use that one. 10 raised to 5 it will become, isn't it? 10 raised to 5. Now that pi square EA by L square, I got it. Pi square is there. So pi square is directly 10. So 4 by 3. Am I correct here? Pi square value is directly given 10. I think I am everywhere right. Oh, देखो भाई 10 power minus 2 8 पर 40 so 400 4 into 10 power 2 10 minus 2 and 2 will become 4. Then pi square is 10 here, and 10 and 1 10 raised to 4, it will become 10 raised to 5. So 4 by 3 into 10 raised to 5. So 1.33 into 10 raised to 5 Newton. That is the P critical. Okay, here see what kind of trap you have here. I told you, no, the trap will be here today. That is how you got trap. Pi square is 10. It's not pi value. You have given the answer. Now you are deleting. Now you are deleting. So very small calculation was needed. Is it too large? Is it the problem solution is too large? Not at all. Not at all. Isn't it? What is the Oriental deflection at free end C? This is your free end C. When a moment is acting, which one will be the correct one here? Santu Salgar is laughing. What happened, Santu? Was that looking tough? I think it was easier. What do you say? What will be the answer for this one? ये बताओ. A. It is just very simple, right? This problem is once again very simple. He's asking what is the horizontal deflection at C. So what will be horizontal deflection at C? See, due to the application of the moment here, yes, I agree. If this is a rigid joint, so BC will get bent. That is correct. That is correct one. BC will get bent. Arey yaar. BC will be bent, but the bending of BC does not ensure the horizontal movement of the point C. The horizontal movement of the point C. Who is doing that? Who is moving that horizontal point C? Who is moving the C point in a horizontal direction? That is the column AB. Due to the moment, the AB will be beam AB will be deflected from its position, and the deflected shape will be like this. That is the delta. That is the final delta. It will remain as it is for the whole system, for the whole column, right? Sorry, for the whole frame. So at C joint also, at that C joint, you will be having deflection delta only. And now who is doing that? The momentum which is applied there, the momentum. This moment is producing that one. So due to the moment in a cantilever at free end, you know already the deflection is what? ml square by 2ei. That's all. So this ml square by 2ei is the deflection. It will be the deflection for point C, the horizontal deflection for point C. Did you get that? Keep on sharing the session link. Yes, all of you please. Using area strain energy method, find slope and deflection at free end for the beam showing in figure. Moment के लिए horizontal. नहीं समझा. What you are trying to ask? Do you have any doubt here? Acha, all of you please share the link. Please share it. Do not forget to share. Have you heard that? Sharing is caring. Isn't it? Share it more and more. Okay. Using area, no problem. Using that word you remain. Forget about. Simply find the slope. No, find the deflection. I'm really sorry. Find the deflection at free end for the beam. Find only deflection at free end. How will you do that? There are several methods, isn't it? Which question? This question or the previous one? Santu, this question or the previous one? Now अभी समझ में आया? अभी समझ में आया? Find the deflection at the free end. बस find the deflection at the free end. Yeah, that's all. Find the deflection at the free end. How you'll find out? How you'll do that? So there are several methods. You can do it by strain energy. You can do it by conjugate beam method. You can do it by that moment area theorem. You can do that anything. No, Santu is asking about this one. Suppose if you are doing that from maybe conjugate beam method. This one is quite easy to do with the conjugate beam. What will be the bending moment diagram? Tell me. This is hogging, right? So you will get the negative bending moment diagram, that is constant bending moment diagram. You will be getting it, isn't it? A constant bending moment diagram. Now if I'll ask you, what is the strain energy there? You can do that whatever you want. Easy. Yes, you can do that from strain energy also. Which one should I? Which one should? See, sometimes I'm also feeling, sometimes I used to do it by anyone, but it's your choice. So maybe if you want to do it by conjugate beam method, here divided by EI, and here you divide it by 2EI. So finally your diagram will look like this, isn't it? Your diagram will look like this. This is your M by EI diagram. Now if it is your M by EI diagram, now it is a rectangular one. It is once again will be very simpler. Why? See, fixed end will become free end, and the free end will become fixed end. That's all. Now if I'm asking the deflection at B, calculate the bending moment at B. That's all. Calculate the bending moment at B. As long as you have a simple diagram, you can use that. Now calculating the bending moment at B, you write it down. Bending moment, while writing down at B, just a second, maybe further if I write down, it will not be visible to you. So here write down the bending moment at B. So bending moment at B, what will get? Bending moment at B. So make it a triangle, rectangle, a two piece. That's all. So one rectangle, this is what is the area of this one? This is M by 2EI. That's all. M by 2EI, and here it is a complete one, M by EI. So M by 2EI into L by 2, that is area. M by 2EI into L by 2 is the total area, multiplied by L by 4 from here to here and L by 2 from here to here. So from this location, the total distance is L by 2 plus L by 4, and it will become how much? 3L by 4, isn't it? It will become 3L by 4. Then add the bending moment due to the bigger rectangle, that is nothing but area is what? M by EI multiplied by length, that is L by 2. This is the total bending moment M by EI diagram. Area multiply with the centroid, that is once again L by 4. Just to calculate it, how much you will get? 3 ml square divided by 16 EI, and here you will get how much? ml square divided by 8 EI. So add this 16 3 8 16 plus 2, so it will become 5 by 16 ml square by EI. That's all. So either you do it by conjugate beam method, moment area theorem, or maybe what? See, already you know that a cantilever problem can be completed through the moment area theorem also. That is very easy. So it's your choice. Practice as much as problems so that you will be able to take the decision during the time of examination that which method I should apply. In a deflection, it is not about which method you know. It is also about which method must be applied to save the time. Did you get that? which method must be applied. And sometimes it is also like, suppose if you have practiced a lot as a particular type of method, that is also once again recommended if you are comfortable enough for a particular type of method. Now what about this one? What about this one? The shear stress distribution shown in figure represents a beam with the cross section. Which cross section? This is the shear stress distribution. Which cross section represents this type of shear stress distribution? Which one represents this type of? Which one represents? Which of the cross section represents this type of shear stress distribution? Yes, that's correct. See, across the in the depth direction, across the depth, actually the shear stress varies parabolically, right? So it varies. Now the thing is that as you have a larger area, a sudden drop down of the shear stress will occur. If you have a lesser area, sudden increase of the shear stress will occur. So as you have a sudden drop down of the shear stress, you will be searching for this one. What is the shear stress distribution for this one? Diagonal member. So continuously it will be like this, Larger area means what? Lower shear stress distribution. A larger area. So larger area, smaller stress. Lower area, higher stress. But completely parabola, not this one. Completely parabola, right? So this is the one. What is the diameter of Mohr circle of stress for the state of stress shown in above? What is the diameter of Mohr circle of stress for the state of stress shown in figure? Can you calculate? Can you calculate that one? See, already I told you the Mohr circle, radius of the Mohr circle, the radius of the Mohr circle, what is that? Sigma x minus sigma y by 2 whole square plus tau x y square, isn't it? That is the formula for radius of the Mohr circle. Now multiply by 2 and it will become diameter, isn't it? So 50 minus 10 will become how much? 40 by 2 is 20 square plus shear stress is 20 square under root. So kitna ho jayega? 20 square plus 20 square, that is simple, no? Twice of the 20 square, so 20 will come out and root 2, that's all. That is the radius. Don't mark 20 root 2. He's asking about the diameter, so do not get trapped. Are you getting my point? So diameter of the Mohr circle becomes twice of that, that is 40 under root 2. That will become 40 under root 2. See, it's not 20 under root 2, it's about 40 under root 2. Now what about this one? A solid circular shaft of diameter d is subjected to a twisting moment T. The maximum shear stress in the shaft is proportional to. The maximum shear stress in the shaft is proportional to. What is that maximum shear stress? It is always the tau is 16T by pi d cube. That's all. It is proportional to 1 by d cube. Isn't it? Tau is nothing but the maximum shear stress in the shaft is proportional to 1 by d cube. It's one-liner question. One-liner. Find the shear force. Find the shear force, moment and axial stress at A. Assume pulley to be frictionless. If it is frictionless, this is a rope. This is a rope. Shear force, moment, axial force. If it is a rope, then he's asking where? at this location. See, rope cannot generate the bending moment, rope cannot generate the shear force, so shear force will be zero, moment will be zero, so either C or either D. Now he's asking about axial stress. Yeah, axial stress is the total load. Now if it is frictionless, the total load will be here. A free body diagram if you construct, no, you get that, you will get that. So 50 kilonewton will be directly transferred to here, this place. So 50 divided by the cross-sectional area of the rope, which is nothing but 0.2 by 0.2 is the, it is a square rope. Square rope somehow it has given. So just divided by Newton per meter square they have given, no. So 0.2 into 0.2 is the what? The cross-sectional area. So 50 divided by 0.04. So it will become how much? 50 divided by 0.04. So into a do. So it will go then 4 एक 4 1 4 नहीं 4 एक 4 1 4 8 then 12.4 12.5 into 100, right? 12.5 into 100 Newton. Now if you want to make it in a kilonewton, then it is actually 1250 Newton, I think. No, 50 was in kilonewton only. The one which we applied here was kilonewton, so you will get in kilonewton. Sorry, it was in kilonewton, you will get in kilonewton. So this is the correct answer. Two shafts of same length, and material are joined in series. If the ratio of their diameter is 2, then the ratio of their angle of twist will be. What will be the ratio of the angle of twist? So if you are joining the two shafts in a series, what does it mean? Joining two shafts in a series. Right. Now two shafts joined together here. And if the torque is applied, what will happen here? If the ratio of their diameter is D, then the ratio of their angle of twist. See, if the torque you will apply, no, it will be throughout same for both of them. Now, the angle of twist for the smaller one may be, the ratio of their diameter is 2. Then ratio of their angle of twist. So, ratio of diameter is 2 means what? The smaller one and the larger one. So, larger one, dia of larger by dia of smaller is 2. Right? So, theta of larger by theta of smaller. So, theta of larger is how much? Theta angle of twist is what? TL by GJ. TL by GJ. J. Now, L is common, G is common, and by G. Right. J is the only thing which will be compared now. So, instead of writing all this directly, I can write down 1 by J, TL by GJ, no? Then here also 1 by J. So, J of the larger, then J of the smaller one. And it will get reversed. So, J of the smaller by J of the larger. Am I correct? Now, polar moment of inertia for the smaller one is how much? For the smaller one, that is pi d. Am I correct? Pi d cube by, I'm writing down polar moment of inertia, that is pi d 4 by 60, 32 will get cancelled. Now no need to write once again 32 also, and here also pi d. So only the thing is that for the larger one, if it is at downward side, so it will become twice of the dia raised to 4. It is 1 by 8. Actually it is 1 by 8 for which one is up and which one is down, man. The ratio wise, which one is up, which one is down? 2 दूना 4, 4 चौके 16. I think 16 will come, no? 16. So 1 by 16. That is the ratio. 1 by 16 is the ratio. 2 दूना 4, 4 चौके 16 यार. 2 into raised to 4 will come out, no? 2 दूना 4 2 दूना 4 4 चौके 16 1 by 16. This is the answer, but actually it is smaller is up, lower is right, lower is down. The ratio wise, theta angle of twist of larger, if it is larger by smaller, then it will be 1 by 16. If it is smaller by larger that, then it will become 16, right? Then it will become 16. Correct? No. A bar specimen of 36 diameter is subjected to pull of 90 kN during a tension test. The extension on a gauge length of 200 is measured to be 0.089 Now, and a change of diameter is also given. He's asking about Poissons ratio. So longitudinal strain already has been provided to you. The Poissons ratio formula, what is that? Minus of lateral strain by longitudinal strain. Longitudinal strain. Now he has already given to calculate lateral strain and longitudinal strain. Lateral strain is how much? Lateral is nothing but whatever the diameter has been changed. That is 0.0046 is the change in diameter by original diameter. What was the diameter? A bar spin 36 was the diameter. So this is the lateral strain. What is the longitudinal strain? Longitudinal strain, if you will calculate, what is the change in length? The extension of an gauge length 200 is measured 0.089. So 0.089 is over the 200 length. Over the 200 length. Now that is the longitudinal, that is the lateral. Right? Now you calculate it, put it there, and you will get the mu value. You will get the lateral strain, you put it there, longitudinal also you put it there. Calculate the value, you will get 0.287. That's all. That's all. Isn't it? A solid circular column of diameter d and is subjected to compressive load. The maximum distance of point of application of load from the center for no tension is for the no tension. Solid circular column. A solid circular column of diameter d and is subjected to compressive load. Right. This is suppose center of the column. It is subjected to compressive load. Now he is asking that what must be the distance from here, from the center, so that if you are going to apply the load over it, so that if you are going to apply the load over it, then no tension will occur. This is your center. Now load must be applied at eccentricity so that no tension. When the no tension means what? Suppose this is your left face fiber and this is your right fiber. Just now I'm taking it over this axis. This is my right fiber. If you are going to apply the load here, obviously the left one will become under tension due to the application of the load. The bending stress will create. Now if I will be thinking about the left fiber first of all will be under compression due to the application of the load. So for the left fiber, if I'll find out the stresses will be P by A is the direct compressive load, and due to the bending it will be having tension. That is nothing but M by I equals to F by Y, isn't it? M by I equals to F by Y, and here F will be My by I. So it is My by I. That is the total stress at this location. It must be minimum, must be equal to 0. If it cannot be tension, at least it must be 0, right? I'm not willing that it must be in under compression. If you solve this one, use that P, then you use that pi d square by 4 is the cross-sectional area. Then moment, you apply that moment P into E is the moment which is acting here, multiply by Y. Y is the maximum fiber distance, that is d by 2. Use the I, that is pi d 4 by 64, and then you calculate it. Finally you will get that E value is nothing but d by 8. So at a distance of d by 8, if you are going to apply the load in between that, inside kern, yes, that is known as kern area. Absolutely correct. I was just calculating. Time pass now. Time pass. You can remember it. I was calculating to do some time pass. You can calculate it also. No man, I was actually teaching you to how to calculate, suppose if you have not seen it. Right. Then what? Next one. The ratio of the length and depth of the simply supported rectangular beam which experience maximum bending stress equal to tensile stress due to same load at its midspan is. The ratio of the length and depth of the simply supported rectangular beam. So simply supported rectangular beam which experiences maximum bending stress equal to tensile stress due to same load at its midspan. Means if the load is provided at a midspan, the maximum bending stress whatever it is going to get here. Acha, first of all, due to this, what is the maximum bending moment? The maximum bending moment is nothing but, suppose P is the load, PL by 4, isn't it? P by 2 will be the reaction L at L by 2, so PL by 4 is the maximum bending moment. Now what will be the maximum bending stress here? So F will be nothing but My by I, isn't it? Or maybe I can say that I by Y is M by Z, M by Z. Now if M is already given, that is PL by 4, PL by 4 into 1 by Z. Z is how much? BD square by 6. 6 will go up, it is now BD square, BD square. So we'll keep it as it is. This is the bending stress. This is the maximum bending stress you are going to get it. And that maximum bending stress will be at the mid of the span, right? At the mid of the span. Now, a tensile stress for the same bar, if you are going to produce, that tensile stress will be how much? Tensile stress will be simply P by A, that is nothing but P by the cross-sectional area, that is nothing but BD. Now he's saying that both the bending stress is equal to the tensile stress. So P by BD is equals to the PL, that is 6PL by 4BD square. 4BD square. What else he's asking? Ratio of the length and depth. Okay, L by D he's asking. So 1D will get cancelled. L by D you will get how much? L by D will become, BB also will get cancelled. 6 will come down, 4 will go up, BB will get cancelled, PP also will get cancelled. So 4 up, 6 down, so it will become 2 by 3, that's all. 2 by 3, that's all. Did you get that? Oh, did you get that? 2 by 3. Yeah, देख रहे हो माउस टूट गया. Have you heard that sound? Okay, so that's all for today. That's all for today. All of you, please take care. Have a nice day to all of you. See, prepare well, join my Telegram channel, and whenever you feel any trouble, feel free to ask me. Civil by Ansari Sir. Right. We'll meet once again. We'll meet once again. No, not an abrupt wait. It is done. It is done. Yeah. All of you, please take care. Thank you, everyone. It was nice to see all of you in a YouTube. So I'll be actually bringing one I know few more sessions. Be there. From tomorrow, maybe Ankit sir will start. Not tomorrow, maybe tomorrow is the Wednesday. So from Thursday onwards, Ankit sir will start, or maybe Krishna sir will start. Any one of them will be there with some fantastic questions. So be there. Thank you, everyone. cup, cup, cup and mouse both. Okay. Good night, everyone.